Okay, so maybe just to start, we can do a quick round of introductions here so that we all know each other. I can start. So I'm Sara. I'm Sara Petti. I'm the community manager for Frictionless Data. I joined the Open Knowledge Foundation now almost months ago. And I'm really happy to be with you today. And I'm really excited to see Evgeny's demonstration.
I can be next. I'm Carlos. I work for the Swiss Poly Institute. I'm a software engineer. I've been involved in different ways with Frictionless for almost a year, I think, more or less. And I'm also excited to see Evgeny and to see that Lily is all good in Texas, I guess, but back with power and this.
And I'm Jen, and I also work for the Swiss Polar Institute, and I'm a research data manager.
I can hop in after that one. Yes, Carlos, I'm in Texas, so thank you for that note. It was a very long week last week, but I am back. I'm Lily, and I'm the product owner for Frictionless within the Open Knowledge Foundation, and it's really great to see you all here.
Chuck McCallum, using Frictionless for a bioinformatics portal. Yeah, I'm just here to learn more and see how I can intersect.
Hi everyone, I'm Logan Byers. I work for the World Resources Institute. We're a global nonprofit environmental sustainable development organization. I work on our open data strategy, I guess kind of open data in our, what we call the data lab. So I'm really eager to kind of spread the message of Frictionless within my organization and try to kind of raise the standards of how we perform and share our data.
Hi, Peter de Smets, based in Belgium, working for the Research Institute for Nature and Forest, involved as open data coordinator to publish biodiversity data, and also involved in biodiversity informatics standards, and using Frictionless to see if we can express standards as frictionless data schemas.
Hi everybody, I'm Evelyn Knight, based in Kenya. I work for International Center of Insect Physiology and Ecology. And I'm a grad student too, and also a fellow at the Frictionless Data Fellowship by Lily. I'm here to learn more about the frictionless tools, and also in a bit to raise awareness among the students and the scientists at ECP, and also to maybe forge ahead and champion for open knowledge and better open science practices in Kenya, I hope. Yeah. It's nice to be here.
Hi everyone, I'm Sebastian. I'm from Datopian. I've been on the calls for a few months back, but today I'm here just to listen to Frictionless Pi because we want to know how to validate data for an open spending project we are working on. So yeah, I'm really curious about this, and yeah, that's basically it.
Hi all, I'm Carolina. I'm data engineer in CVD, so you probably know my colleagues, Oleg and Torben. They are quite often here on the calls. So yes, I'm in Switzerland as well. And yeah, I'm here to learn new stuff and to get to know you as well.
Hi, I'm Richard Osler, based in the UK. Work for Rothamsted Research, which is an agricultural research institute. We're using Frictionless data to manage more and more a lot of our open data sets. And I'm also working on a data carpentries lesson using Frictionless data for agriculture.
Hi, I'm Simon Willison. I heard about this call on Twitter about 10 minutes ago, and it's 6 o'clock in the morning over here. I'm in San Francisco. I'm working on an open source tool called Dataset, which lets people publish data using SQLite. And I've been wanting to learn what frictionless data means and how I can use that for packaging metadata for a while. So I'm tuning in to find out more about that.
Hi, my name is Giuseppe. I'm a postdoc in Switzerland at the IDEAP Research Institute. I'm mostly working with energy geodata. And yeah, I've been a user of Frictionless for a few months now.
Hi, I'm João Gomes. I've been working with telecommunications data for a long time now, and I'm interested in getting to know more about Frictionless and how we are going to use that in several problems that we have today in telco industry.
Hey everybody, my name is Adrià Mercader. I work with Lily and Sarah at Open Knowledge. I'm the tech lead. And although I've been working on frictionless data in the past, it was about the previous incarnations of the libraries. So I'm really eager to see what Evgeny has done with the new version. So that's what I joined the call.
I see that Evgeny has just arrived as well, so that's great. Are we missing anyone for presentations? Augusto, maybe? Do you want to say a few words?
Well, hello. Thank you for inviting me. I have been using frictionless data for a few years now. We use it to publish an open data set with the data package standards, and I think it's been quite useful, and I'm eager to learn more with you and share our experience. So thank you.
Thank you very much. And now, Evgeny, I don't know if you want to sort of like introduce yourself before giving your top presentation.
I was muted. Yeah, I'm waiting because I kind of got a massive leakage in my apartment, so it's raining just inside, like on the balcony. But it's fine, I hope. Yeah, I'm Evgeny. I'm a tech lead of the Frictionless Data project, and I've been working on. I think I got a little bit what Adrià was saying. That yeah, I've been working on these libraries improvements and making them as one data framework to improve user experience and just basically make it easier, like to many aspects understand, etc. Because previously we had like 12 main libraries and it was like very overwhelming for people. So let me share my screen. Can you see it?
Yes.
Yeah, thank you. Yeah, now for Python we have only one main library. It's now, like we call it now, a framework. It's called Frictionless Py. So it's on GitHub on the PyP, and we still maintain our like previous generation libraries and fix bugs and merge pull requests, and they still support Python 2, and this framework is solely for Python 3. So yeah, I think I need to quickly introduce the framework, because my presentation is mostly about the transform capabilities. But yeah, I think I need to go through the whole thing firstly. So yeah, so the Frictionless framework has 4 main directions or aspects or actions. It's for describing data, and it means like creating metadata for your data. And as I think many of you know, that the initial idea was to create data specifications, frictional specifications, and it was only about metadata, how to describe like your resource, what's name of your resource, what's columns your data has. And this part, describing data, is the closest to the frictional specifications. And so a simple use case, you run frictions describe command. It returns schema metadata, for example, what's your data types in your table. You save it, you can edit it in like as YAML or JSON, and then validate your data based on like inferred metadata and your edits. And the second part is extracting data, and basically it's I think the simplest part. It's about data reading. So mostly it's like it's I think kind of like synthetic part of the framework, because we read data all the time, and probably it might be omitted as it's kind of like synthetic action. But consider you need to like quickly read HTML table from somewhere, and you just run frictionless extract, and you can see what's your like data as table or something from database, etc. But yeah, so the next one is data validation, and it was previously known as good tables, and now it's a part of the Frictionless framework. And aside from minor API changes, it's basically the same. So previously you ran good tables validate in Python or in command line interface, and now you can do the same with frictionless validate. So it's really close to what good tables was. Still it is. We still support good tables. And there is a new part called transform data. Previously it was, we had a project called data package pipelines, and also data flows written by Adam Karif. So, but we have never like had some built-in method of data transformation. Transformation means like adding fields, filtering rows, sorting, like joining tables. And now it's an attempt to incorporate transformation into like one framework. It's not based on data flows. It's based on the PETL project. And yeah, also I think I need to mention that describing data part is a kind of replacement. It's not like exactly describing data, but at least these two are like a replacement of table schema and the package libraries. So validating is a replacement of good tables, and transform data you can use, for example, instead of data package pipelines. Because transform is really new and it's still quite raw, so the design like architecture is almost in place, but we might or you might run into some bugs, problems. So currently I recommend to start like playing with the transform API, but not to use it in production. Although like for data wrangling or something like this, sometimes there is no like real production. You just need to like, do your research or something, so probably it's fine. But please feel free to report any problems and maybe missing steps. For example, I just working today on the presentation, I realized that we just really miss like field rename step, for example, because I wanted to rename a field and there wasn't a step for it. I mean, step, it's a part of transformation pipeline. Okay, so yeah, it was a quick introduction. So let me show you the main topic. Also, yeah, I think we haven't shared it yet, but now, as you can see, now we have a framework documentation portal, which I hope will improve like documentation reading experience. We started to do like a proper cross-linking, like it supports field, for example. What I was saying, field remove. Yeah, supports like proper search. So also if you spot something like suspicious on this site, like a bug or something, please also report. And yeah, and regarding reporting errors, now it's only one repository. Also, even if you need to like fix something in like tabulator or good tables or libraries like this, feel free just to use this issue tracker. Okay. So yeah, let me share you new transforming data API. So it's in the guides section. You can read because it's kind of like a long read, relatively. Under the guide section, it's called transforming data. There are two articles. The main article about basics and main concepts, and the second about included transformation steps. So yeah, so in a few words, the transform API is created to be like as much as possible close to concepts you already use with Frictionless. For example, you just create so like the main probably object in Frictionless, so it was the main project in data package library resource, and then you just use this resource as a part of transform call. So it's quite simple that just you have a resource like data table and you apply transformation steps, like nothing more except for these two ideas. And also you can transform packages, and it's kind of nested. So you like transform your, you also create package separately, and you can, for example, add a resource, and then you can transform resources within the package like as a nested transform call. Also, we are working on the pipeline capability. It's a declarative way to define your transformation pipeline, and it's even like less tested than transform API in general, but it will be like really useful for Frictionless server API, and like some like cases when you need to share your pipelines declaratively, not as a code. But for now, I think it makes sense just to omit the pipeline thing and talk about like transforming resources and packages. Yeah, this article includes some high-level overview of how it works, and you can also create custom steps. And as I said, it's based on the PETL library, which is kind of like battle tested. So it supports about like a few hundreds of transforms, I think, and we try to make like the API nicer, just reworking how transform steps grouped and named. So we have less than few hundreds, just because we kind of like grouped some steps. Like instead of having like 10 join steps, we have one that accept options like join, right join, left join, outer join, etc. So yeah, there is a second article. It describes the built-in steps, which you can find as a part of core Frictionless framework, and it's grouped by like transformation targets. So just to make it easier to find the step you need, you just think what you're going to change or affect. So for example, if you need to convert a cell, just one cell in a row related to some field, so you look for cell steps, or if you need to filter rows, you look for row steps, and adding, removing fields, field steps. I think the most complex is table steps, because it includes some sophisticated operations like join or melt, recast, transpose, and on the data package level, you can also work with resource steps, like adding, removing resources. It's the smaller group, because it's still like data transformation is about like resource mean like it means a data table, and usually work on a data table rather than rather than managing like resources within a data set. Okay, so yeah, I think it was an introduction, and yeah, I need to say it again that it's kind of like raw, and I'm just exactly now like working on fixing some problems with performance, and by design performance should be really good, because comparing, for example, to data flows, it doesn't cast your data on every step, and also has some important design level, architecture level improvements. I hope. I mean, of course, the Falls has its own strengths, but in lower level we still facing some problems. So probably at the moment request table will not work, but I'm working on a fix. Yeah, so I'm going to show a quick small example just like data wrangling, and I decided it to be about cars. I don't know why. So yeah, I created a collab notebook. It's a second. Okay, I think we'll share the link later. Sorry. So it's a collab with Google's project, and it's basically a Jupyter notebook, just hosted by Google Google Research project. So yeah, it's very simple, just to show the idea, and kind of regarding data research it's useless, but at least something. So yeah, we start from installing Frictionless, and we also need two plugins, and you can install plugins using this Python notation. So we install a HTML plugin and a Pandas plugin. So, and first, yeah, so it's grouped by resource we are working on, and the first resource. So the idea that I found this article in Wikipedia, and it provides information about electric cars, and I was interested by their share in the whole cars population by country. So in Wikipedia, it's not really machine readable; it's human readable. Maybe I can actually export it as a CC, but I just didn't try just for demonstrational purpose. So let's say we have something not on Wikipedia, but somewhere else. It's a table, kind of for people. It's there is a mix of numbers and notes, texts. So it's not, you can just copy and paste into Excel. It will not work because it's just for humans mostly. So what we do is we create cars resource, so frictionless resource, and what we do is we use a transform function from frictionless, and it accepts resource. First argument is a resource, and in our case it's kind of like a raw resource, raw data table. So we use this link, we name this resource, we say that it's a HTML, and also the most important thing for this example, that we use a HTML dialect and set a selector, like CC selector, to find this table. It's like there are few tables, but just you need to believe me. This one has this selector, and so having this resource, we just have this table as it is, with these like headings and messy data cells. And what we do is applying transformation steps. First of all, we First of all, we limit the table because it also includes these two rows. We convert country. Sorry, convert a country name because it has nodes, and also sorry. It's about my leakage. Yeah. So basically, it's really similar to, I guess many of you do, just working with data. It's a simple string manipulation. So we remove this thing from country. We we add a new field called share, and extracting a number from this column. So as a result, also we remove all the fields except for country and share. And as a result, we just run this code and we get a schema containing two fields, country and share. And as you can see, share is a number. It was like automatically inferred. And we just read first 5 rows. And so basically from this table, we got a table like this, just 2 columns, and it's already cleaned. The second part, and a few things to mention. So the idea of the framework is to make things composable. So you create this scarce resource and you can reuse it later. So even though you have already like read some rows, you can then open it again or use in next transformation step or join somewhere. I'll show. So just keep in mind that we have this scarce resource. Second one is yeah, I didn't like say that what I was going to check, but it's related to electrical car share and GDP, domestic product. It's really like a naive idea, but I just wanted to check maybe there is a correlation or something. So also I wanted to show how to use existing data packages. So I just found this GDP data package. I would rather use GDP per capita, but we have GDP only. So I just found this data package and found the data package descriptor and created this data package like in Python and asked to just return me a GDP like first resource. And similar to the first step, we apply some transformation steps to get the data we need, because it's initially it has like country code, and it also provides information for many years. So it's not only like for 2016, but also includes historical data. Okay. And yeah, and as an output on this step, we also got a two column table having country and value columns. Here we go. Yeah, so for example, for one country there are many values for every year available historically. So now we have two resources, two tables. And when we talk about tabular data, a resource is the same thing as a table. If you have non-tabular data, resource can be like a PDF or something, but in our case, it's kind of like interchangeable. And yeah, the second thing I wanted to add when I was talking about this step, that second important principle of the frictionless transform, that basically the underlying PETL library does really similar things, but what frictionless adds is metadata handling. So you always get not only your data but also metadata. So if you add a field, it's not only a field in a CSV, it will be added into your data package, for example, or data resource. So as you can see, all these manipulations are reflected in a schema, in a resulting schema. So yeah, my idea to check a correlation, and here we use a correlation between share of electrical cars and domestic products. And here we use a join step. It's more advanced than like simple steps because it joins two tables. It's the same as in SQL when you have like two tables having the ID column, and you say like join them, and there will be one table, and based on the ID column. So in our case, we join our cars and product resources. Product, right? Yes. And we get a combined table just from these and these data sources. And it's already like cleaned and simplified. I mean, columns are not used columns are removed. So what we can do with frictionless, we can export to Pandas. Just you might be like really familiar with Pandas and have experience. So just after initial like data describing, extracting, validation, you can just opt out to use some another instrument, SQL, Pandas, BigQuery. We're working on the Elasticsearch support because it provides like a lot of good visualizations. And in this case, I used Pandas. And basically, yeah, it's really it's really just funny, a funny example of creating a plot and a bar chart. And as like a small scientist, I just get this that it seems that overall GDP of the country doesn't really affect or affect negatively on a share of electrical cars. But if we like used, if we have used GDP per capita, probably we will find a like proper correlation because, for example, Norway have a lot of electrical vehicles, and I think GDP per capita is really impressive. So yeah, my experiment just failed, but it wasn't the point. So the last thing, I just wanted to show that after all, you can have this, because parts are reusable, you just use these resources you created before, you just use them to create a package, and you can export it to SQL, for example. Here is an example of just I run this against my test database, and I got tables on my SQL server. You can do the same, for example, exporting it to a zip archive, and also we're working now on fixing some problems with this export, but it will be resolved anyway, like very quickly. But this framework is hopefully will be used like for, and will be stable for kind of like foreseeable future. So once we resolve some minor problems we have, I think it will be really useful. So you might use here like package to zip and that data path, and then you can just share this data zip archive with your like colleague, and he or she might continue your experiment, for example, switching to GTP per capita. And basically, I think that's it. Maybe I'll pass to Sarah, or maybe questions.
Yes, thank you very much, Evgen.
Thank
That
you.
was very, very nice. And thank you for staying, even if you have a leakage on the balcony. I mean, I think that a lot of people have questions. Yeah, I've seen some in the chat already. I think that Augusto had one, for example. But yeah, just feel free to maybe raise your hand, and then I will give you, I will hand it to you. Okay, Peter.
Thanks for the presentation. This is really cool and fits perfectly with a use case where we are having to transform data from one format to another, starting with a data package. And we went over SQLite to be able to use SQL. Because the important part was that we could share the transformation to a non-technical audience. And I think that might be possible here, like sharing the individual steps. But if I understand correctly, the output of the transform is still a data package with all the fields described that could then be exported as well. It is changing the metadata and the resource descriptions with every transform step. Is that correct?
Yes, yes. Like there is no requirement to be a data package. Like in, for example, data package pipelines, you need to work with a package. Sometimes it's a limitation. Here you can use a like resource transformation if you only have like one table, or you have a few tables and need to join them and clean. But yeah, the main idea comparing to PETL, that it's tied to metadata. So you always have a schema and like data tapes, etc.
Okay, so the output could be a well-described data package of your transform data. Then one specific for all the steps is subsampling available? Let's say you group data by hour, but you have many records for an hour, to then just take the first record of that group. Is that one of the transformation steps that is supported?
Sorry?
To be able to take the first record in a group, is that a transformation step that is supported?
Yes, wait a second. I'll show it again. Yeah, so for example, for this case, we have a row, like slice rows, I guess. So you just can head or tail rows.
Okay.
And
okay, great.
Go ahead. Yeah, and in general, it's, we try to still be as close as possible to like Python programming. It's yeah, as I said, like we're having some like minor problems internally. So this example might change a little bit what regarding custom steps, but it's still under the hood. It's just a Python programming. So even though it's not like if like a head step is not good enough for you, for your case, for your business logic, you can just add a custom step and do whatever you want with, for example, resource, have opened resource. Here we open a resource. Open resource always has a sample and sample and fragment properties. So you can just check a small part of your data. And because it's just a Python, you can just have a custom step to inject your sample exploration and do whatever is needed.
Okay, thanks. Excellent. I'll probably use this.
Thank you.
Can I ask a direct follow-on to that, which is just how complete the metadata transformation is? One thing that has been most useful to me in like the table schema is where you can put optional values like the min and max of a numeric field, whether a field is required or optional. And I'm kind of wondering, as with the built-in frictionless transform steps, as these fields are combined, does that kind of logic continue to combine? So for instance, if you multiply two numeric fields, the new min value should be the multiplication of their min values.
Maybe I didn't fully understand, but are you talking about
really when combining fields, whether the metadata such as the minimum and maximum values are kind of logically transformed as well?
No, at the moment, logically no, because it will mean it would mean something like multiplying mean values from two fields, right? No, but it's again kind of area for custom steps that can be written and reused. But I would happy to discuss it maybe for adding anything you guys have in mind. Just create an issue, because I think it's kind of like a big project, this transform, because it has a lot of steps, etc. I think it will be a lot of work improving this, and the new steps, new ideas.
Yeah.
Be
okay.
happy,
Thank you.
Yeah, to include it.
So I see that you have your hand raised since a long time. You can go next.
Yes, thank you. I don't have exactly a question, just to thank you for the demonstration. Very useful and small but impressive of the capabilities of the framework. And also to thank you on your reply on the bulk CM issue that I exposed in the discussion forum of Frictionless. Just that. Thank you.
Thank you.
Any more questions? Logan has another one. Go for it.
Yeah, I do have another question, which is you kind of discuss serialization maybe through the pipeline object. And so I was wondering if you could just kind of describe how that looks. I think this is also related to helping non-technical audiences understand the information or the transformations. Yeah. And essentially, I mean, just for a little more to round out the question, I've been really impressed with PDAL, which is the point data abstraction library. It's like GDAL for point clouds, in which their pipelines can be completely expressed as a nested JSON object, which is we can debate whether that's more convenient or less convenient, but it certainly is transferable and can be used in many contexts.
Yeah, it also can be expressed as just a JSON object, or now we use a YAML as a default, but we still of course support JSON. So yeah, it will look something like this. So just pipeline, and we set a type. It will be a resource transformation, and basically it's the same that I showed previously, but written as JSON. So for step names we use and yeah, in general, it also, this pipeline object class follows rules that other metadata object we have, like resource or schema, follow. So it also will be validated, and it's still work in progress, but I have like kind of big hopes for this, because it might be exactly what you said, like a way to express complex and nested transformations.
I see that August also has his hand raised. So
thank you.
Здравствуй, Евгений. I just wanted to thank you. Спасибо большое. I have been using Frictionless for a while now, and you have always been very quick to address issues and very helpful. My question was just a little bit about, actually two questions. One is, are you familiar with the Dataflow Python framework, and is there some overlap between the features of data flows and frictionless transform? And the other question is, if you define your transformation steps using classes, can you export the pipeline to document the transformation somewhere?
Да, спасибо, Густо. Да, возможно использовать. Does it work for everyone? No? No. Okay. Yeah, so regarding the second one, no, I think it's not possible to just like have something like this and say that just convert it to JSON, because it's kind of like a Python code, so it will be interpreted by Python. But if you need something like this, it's better to convert it to JSON, to dictionaries, and run as a pipeline. So it will be possible to run as a code and like from command line. And regarding data flows, yeah, there is a overlap definitely, and I would say that it's kind of like different approaches in many areas, and I worked a lot with data flows, and what I wanted to like propose as a different like way to work with data is, first of all, it's like ability to work only with one resource, and which makes like it composable. And secondly, yeah, I haven't touched, I think, a lot of important details. For example, comparing to data flows, this transformation framework doesn't convert or cast your data on every step. We haven't yet profiled or tested the performance, but it should be much faster because it Frictionless use a raw object, which is a lazy object. So if you don't ask to, if you don't access raw, I mean a cell within a row by name, it will not be converted. So there are some different approaches and improvements, I hope. So I would say, yeah, it's probably, it makes sense to, for solving some problem, it makes sense to try frictionless and data flows both and decide what works better for you. But from our position, we really wanted to have this as a complete data solution within Frictionless. So we tried to include data flows actually initially, but I think what is good about PTL that runs this frictionless transformer, that it's really battle tested and really already comprehensive. So I think it has I don't know, if data flows has 20 steps, PTL has 200. So yeah, so just I think it really overlaps with data flows, but it's just a different different technology.
Thank you. I'm really sorry, but we're running out of time here. So I think that we have to stop the questions, sadly. But I would invite you to join us on our Discord channel, where you can ask questions, and sometimes you have the privilege of Evgeny answering to them. And also, for some more serious issues, I will link you to our discussion on GitHub here. So you can have everything there. And also, maybe you can follow us on Twitter to know what's going on about. You will find the link to the Discord chat and the Twitter account on the agenda, which I already put in the chat in the beginning. So thank you very much, everyone, for joining. Thanks, Evgeny, for this demonstration, which was really, really great. Next community call should be on the 25th of March. And we're going to have a presentation by Giuseppe and Oleg. I won't say much about it, but you will read about it very soon. And we have just a few more announcements to make. So as most of you know, we are reviewing the frictionless data documentation, thanks to the support of the Open Data Institute. So that's the documentation that Evgeny was showing. Have a look at it and fine. You can have a look at it and it will change over time. The transformation will be over more or less by the beginning of April. And the other thing is that I will invite you to submit your proposal for a talk for the CSV conference, which is happening on the 4th and 5th of May. You still have 3 days to apply, so please do. And Evgeny just shared the notebook. Yes, yes. So thank you very much, everyone, and hopefully see you next month.
Thank you. Bye-bye.
Bye, thanks.
Thanks, bye.
Bye.
Thank you.
Thank you.